Well, it's time to take a look at some homework questions from week 9 of Math 2. Question number 1 as an example. So inspect the graph of this. So you could use a graphing calculator, but to save a little time, I'm just going to say that is a line. It hits the y-axis at 2, and then its slope is 1, because there's a 1 in front of x. So that's what the graph would look like. Determine if it's increasing or decreasing. So this is always increasing. So it has to be something that's always increasing. So if it says decreasing, that's out. It's increasing always because it's a line with positive slope. I'm liking that answer. The function is increasing because it's a graph with a line with a positive y-intercept. The y-intercept has nothing to do with it because the y-intercept could be whatever. It could be a negative number, and then it would be a line like that, which is always going up. So this one, I'm not falling for that. And then randomly chosen next is number 3 because of the way they drew this. All right, let me try to make sense of this. The graph is shown to the right. Okay, I get that part. Identify where it's increasing. Oh, okay, that's not bad. So increasing means going from the bottom to the top. So that means that from B to C, it's increasing. Then this is another part where it's increasing. So this one was B to C, and they're actually writing them like this. And then this would be increasing from D to E. So D to E, also increasing. And then this is increasing from F to G and also to H. So I guess I would have to write F to G and then also G to H. But it seems like you could put those together and just say from F until H. So it has to have BC and DE for sure. BC and DE for sure. So this one is possible. BC and DE. BC and D, no, those don't have BC and DE. Sorry, buddies, but maybe next time. And then let's see, what did they change? Then they put F to G, so F to G, or is it F to H? And that's where I was saying they should put those together and say F to H. So this is the winner. And then there's a continuous functions. It has critical numbers at A, B, C, and D. And actually critical numbers could mean the derivative equals 0 or the derivative does not exist. So use the sign chart. I did one of these just a minute ago in the lecture part. So basically this means negative slope, so it's going down, and then it's going up, and then it's going up, and then it's going down, and then it's going down. So that's the general shape of it. So something like down, up, down, and then down. So that means that it looks like it would have a maximum right here, and it would have a minimum down here. So does it have a local minimum? So yeah, because it went down and then back up and the derivative equals 0 down there. So I'm confident with this answer. Yes, there's a minimum. A local maximum. So this means the derivative does not exist, and yet it went up and then back down, and it's a continuous function. So there can't be any holes in the graph. So that means basically because it said the derivative does not exist, then this would be like a cusp or a sharp point like this. But that would still be a maximum because it would still be at the top of the hill. Oh, I should have read the whole sentence. All they're asking me about is A. and A is the minimum. So this word extremum, that means it's combining the minimum and the maximum. So it's basically saying there is no local minimum or maximum, but they're saying them both because extreme means the extreme biggest or the extreme smallest. But anyway, this is a minimum, so C is the winner. And then I wanted to choose this one because of two things. One is they say the partition numbers, and I call these the critical values. And in the last problem, they called them critical values as well, but just right here, they decided to just change it to partition numbers. And what they mean by partition numbers is, like on this last example, it's partitioning. Here's the positive, the negative, etc. So these, A, B, C, and D, these are the partition numbers. So find the critical values. First of all, the derivative, just use the power rule. That's going to be 3x squared minus 75. So there's the derivative. And then find the critical values. So take the derivative and set it equal to 0. So you could then add 75 to both sides, and it'll say 3x squared equals 75. And then divide by 3 and divide by 3. So it's then going to say x squared equals 75 divided by 3 is 25. And then when you take the square root of both sides, make sure that you put plus and minus the square root of 25. So that means x equals positive and negative 5. So basically on the number line, here's negative 5 and here's positive 5. And those are the critical values. Those are also the partition numbers. And then they didn't say anything to do with it after that. So basically that's what they're looking for. I was just looking, maybe I chopped off part D, but I don't see anything there for part D. And then the reason that I want to do this one is use a graphing calculator. So I would rather just do the calculus myself. But let's see why they're saying use a graphing calculator. So the critical numbers, so that means find the derivative and just go along and use the power rule. So the first one is 4x cubed. The next one, multiply, that's going to be minus 9x squared, and then plus a 5. And I now see why they said use a calculator. Because this has an x, but this does not. If this would have had an x, I could have factored out the x and then done quadratic formula. The way that it is, we need to use a calculator. If it was later in the semester, we could use Newton's method, but we haven't done that yet, so we have to use a calculator. So I prefer always graphing the original problem. So I'm going to go x to the 4th, and then minus 3x is cubed, and then plus 5x. And then first of all, zoom standard, and hey, that's pretty nice. It showed up on the screen. I don't have to chase it around. So notice that when we took the derivative, it has an x cubed. So when you set this equal to 0, that means that there's 3 solutions. And if you look right here, the derivative equals 0, there's 1, 2, 3. So there's 3 solutions to this. This one is the minimum. So to find out where this minimum is, I can do second calculate, and you guessed it, it is number 3, find the minimum. And then I just have to move the cursor to the left. So move the cursor to the left to where you think the minimum is. Now move it to the right and hit enter. And then move it to approximately where you think the minimum is. And right now, they're only talking about the x's. So all I need is the x. So I get x equals negative 0.656. I don't have my glasses on, but I'm pretty sure that says negative 0.656. And then Okay, but they rounded it to 2 decimals. Okay, so this was correct, but they rounded it to 0.66. All right, then find this one right here. And then this at the top of this hill, this is a maximum. So get second calculate, choose the maximum, and move until you're a little bit to the left of it, hit enter. Move until you're a little bit to the right of it, hit enter, and put it fairly close to where the maximum should be. And that says x equals 1. Do they have x equals 1? They sure do. And then for this third one right here, so that is where there's a minimum. So second calculate the minimum, and then you just need to be a little bit to the left of it, hit enter. A little bit to the right of it, hit enter. And then approximately right there, which is x equals 1.906. And then do they have 1.906? Well, they do, except they rounded it. Okay, so I got this one, I got this one. I also got x equals 1, but I was so excited about pointing out that they got x equals 1 also, I forgot to write it down. Approximate the critical numbers. So we got this one. I don't know why they're throwing in a 287. They're just making that stuff up. So for these three, that's part C right here. And then, so basically in the lecture, I made up one like this where I put the numbers on the number line and they made a little box like this instead. So basically I can make a number line. As far as x, they're using -7 and 0 and 7. Okay, so they're using -7 and 0 and 7. And then they're saying the derivative is positive on the left side of the graph. So that means that it's going up. They're saying the derivative equals 0 at all these places. So the derivative equals 0 right here. So I'm pretty sure that's going to be a maximum point. And then the derivative is negative between -7 and 0, so that means it's going down. And the derivative equals 0 when you get to 0, so this is going to be, looks like it's going to be a minimum. And what else? Oh, interesting. So the derivative equals 0, so this part is saying it's going down from -7 to 0. So I did that, it's going down. Then the derivative equals 0, so it basically flattens out. So it's going down, then it's going to flatten out, then it's going to go down. This is an exaggeration, but that's basically what it's supposed to do. So then it's supposed to flatten out for just a moment, and then it's supposed to go down again. All right, that's what these are saying. And at 7, the derivative equals 0, so this is an important point. And then finally, the derivative is positive on the right side of 7. So now it's going to start going back up. So my graph looks something like this. And do they have one that looks something like this? Well, if I look at the two ends of this one, they're both going up, and I have one that's going up and one that's going down. So this one, no. This one, they're both going down, no. So right now I'm only looking at the ends. They don't match mine. And then this one is going this direction, and it's going down first, and it's supposed to be going up first, so this part's not right. And then finally this one is going up, and then down, and then flattens out right here, and then goes down, and it looks just like mine. So letter A, you're the winner. Okay, just one more. So with this kind, of course, this is on a piece of paper, but what you're supposed to do is grab it and then match it up. So you're basically just matching. So for number 13, the slope is positive and the second derivative is positive between a and b. So slope is positive means it's going up. Second derivative is positive means that it's concave up. So it has to be both be going up and concave up. So on this one, I went down for a little while, then I went up. So if I just chop off this part that went down, erase that part, and then this is both concave up and going up. So that looks like this one. So letter C goes with 13. So then you just grab it and then drop it in the box. Okay, let me just do one more. And then that is the derivative is positive. So it's going up, but it's concave down. So this is saying it's going up. This is saying it's concave down. So it has to be going up, but it has to be concave down. And again, it has to be going up the whole time. So if I take this graph and I just erase the right side of it, because this part's going down, and I just want the part that's going up, then it should look like that. And that looks like this one. Boy, they didn't try to trick us, did they? They put them in order. Or at least for the first two, they put them in order. Okay, then, I know I said that was the last one, but I just want to do one more. Because this one has a fractional exponent. Inflection points. So this means the second derivative. So we need the second derivative. So when you take the derivative, do the power rule. So there would be the 2, and then take the 5/3, put it in front and multiply, and then subtract 1 from the exponent. And 5/3 minus 1/3, 5/3 minus, sorry, I just said 1/3 because I was grabbing my calculator. 5/3 minus 1, go to math, change that to a fraction, is 2/3. And then that is the first derivative. And the derivative of 2 is 0. That's why I didn't put anything right there. Now go on to the second derivative. So I could simplify this a little bit because this would be 10 over 3. So I'm just going to write down that 10 over 3. Now take the 2/3, put it in front and multiply. And then subtract 1 from the exponent. So then 2/3 minus 1. 2/3 minus 1, change that to a fraction, is negative 1/3. And then, that did say negative 1/3, right? Yes. And then before I finish, I just want to, before I answer their question, then I want to simplify this. So this would be 20 over 9. And then I don't like dealing with negative exponents, so this means I would move that to the bottom. And then notice that once the x is in the bottom, that means x equals 0 is a critical value. Because that would make the second derivative undefined, so there must be something interesting, or there could be something interesting happening to the graph there. And then let's graph the original and find out. So the original, sorry about that, had 2, and x is raised to the 5/3, and then plus a 2. And then zoom standard. And what does the graph look like? So it basically looks like this. I'm going to draw an exaggeration of it. It basically looks like this. And then this part is concave down, and this part is concave up. And it's x equals 0. Like I said, x equals 0 is the important point. That's the inflection point. And then what did they say? So the inflection points are, so basically I just need to go back to the graph and plug in a 0 because they said the point. So that's 0, 2. And what are the inflection points? Select the answer below, fill in the answer box. Okay, so the point, inflection point is 0, 2. All right, I said that was the last one, but I just want to quickly look at this one. So when you take the derivative of a natural log, it's going to be 1 divided by whatever's in the parentheses. And on this one, I don't want to work out all the details. I just want to show you about the derivatives. So that takes care of the derivative of the natural log. And now I need to take the derivative of this, which is going to be 2x minus 8. So then times 2x minus 8. But then they said, what about the second derivative? So now we need the derivative of the derivative. And for that, I think I need more paper. So for the derivative of the derivative, I'll need to use the quotient rule. So that's this one. So the derivative of fraction, you start by taking the derivative of the top, then the bottom left alone, minus the top left alone, and the derivative of the bottom. And then the bottom will be squared. So start on the top. The derivative of this is just a 2. And then leave x squared minus 8x plus 52 alone. And then minus, now just copy this one down, 2x minus 8. And then take the derivative of this, which is going to be 2x minus 8. And then the bottom, gets squared. So there's the second derivative. All right, so that's the main point I wanted to make on this. And then you would set the top equal to 0 and also set the bottom equal to 0 to find out the critical values. Here you'd have to multiply it out and combine like terms and eventually do the quadratic formula. And then this one, you would basically just square root both sides and then you would do the quadratic formula.